Hello to our ladies and gentlemen. How are you today? Continue by looking on a different point about our lessons that pass on this channel. Today we need to discuss on transverse waves and longitudinal waves. Most of you don't know how to differentiate the two types of waves, but are very important to our physics. See how transverse and longitudinal waves are different. Firstly, by starting, we know that a wave can be defined as disturbance that carry energy from one point to another without changing the medium. That is what we call a wave. A wave is a disturbance that propagates energy from one place to another without transporting any matter. That is what we call a wave. We know most of examples of waves. We have water waves, waves in water. Those are longitudinal and transverse waves, but we don't know clearly how the difference is. Also, sound waves also is kind of waves. We have also electromagnetic waves. We have spring waves. There is different types of waves and examples of waves, but according to transverse and longitudinal waves, this is the time to see the difference between the two waves. By looking on this picture clearly, we see the wave in water. What kind of wave in water? Is that transverse or is this longitudinal? Let's try to look together the difference between the two waves. What is the difference between longitudinal and transverse waves? By looking on this picture, this is spring waves. The waves in springs. The wave in the spring may be transverse or longitudinal waves. Depends on the vibration, how vibration are moving. When do we have longitudinal wave? Longitudinal waves are the waves where vibration are parallel to the direction of travel. For longitudinal waves, it is clear that the direction of wave and the direction of vibration are parallel or are in the same line. That is where we say we have longitudinal waves. For instance, when you have a speaker, sound wave moves in terms of longitudinal waves because the vibration are parallel to the direction of wave travel. In terms of compression and rarefaction, compression is where particles are closer together, whereas rarefaction is where the particles are further and separately are not close together. Those are what we call longitudinal waves. The particles moving of vibration are in the same line or are parallel to the direction of travel of a wave. Also, we have transverse waves. For transverse wave, unlike longitudinal wave, transverse waves are the waves where vibrations are at right angles or are perpendicular to the direction of wave travel. The vibration of particles moves in terms of up and down, so that the vibration are up, down, or are perpendicular to the direction of the wave. The direction of wave propagation is always perpendicular to the vibration of particles in terms of crest or trough. Those are what we call transverse waves. In longitudinal waves, the vibration of particles are parallel to the direction of the travel of wave, whereas at longitudinal and at the transverse waves, the vibration are perpendicular to the direction of wave propagation. So this is how a longitudinal and the transverse wave are different. They are totally different according to the vibration of particles. And next time we shall discuss on the next point, which is very important to us, which is very essential, where we shall see clearly how you can classify different types of waves. How can you classify different types of waves? We shall look together it. Thank you for watching. We shall meet next time. Thank you so much. Together we are. Thank you so much for our participation.